Hello, this is video V as in Victor, and in this I'm going to talk about the main program for example 8. Our first real OOP program, the source code file specifically is EX08, I think, yes, EX08.cpp. And if you haven't yet, you'll want to download that from your email and perhaps have it open in a separate window over here, or maybe even print it out so you can look at it, because I'm going to assume you have a copy that has line numbers, and it'll make it a lot easier to match up what I'm saying about the specific lines of the program if you're looking at it off to the side somewhere. For example, and I'm going to have to pull my glasses off a lot so I can read up closely, lines 1 through 9 are all comments, // Don't view those as optional. Please put header comments in your file, your source code file. Thank you so very much. What's new there? I did put the build command for the Mac. Line number 8. Line number 8 says instead of just the G++ example8.cpp, this time we're going to need 2 files because we've got code in 2 separate source code files that's going to need to be compiled separately. Separate compilation it's called, where each one of those individually is turned into machine language. And then the linker finally has a non-trivial role to play. Not only will it link us to the standard libraries, it'll pull our code together from our 2 separate binary files. Okay, that's enough about that. All you got to do is remember, don't try to compile and run example 8 all by itself, or it's going to tell you that it can't find everything it needs to know. Okie dokie. And then let's look at lines 10 and 11. We've had #include IOStream using namespace std so far all semester, ever since we've been using C++. And I think I kind of waved my hands the first time we looked at that. I might as well put these down. I don't know when I'm going to put them back on. And said, you know what, just put that in there. Don't even think about it. Well, let's think about it a little bit. The things that start with £signs or hashtags, whatever you want to call those, the lines that start with that and that on this particular editor, they turn brown when you type them in. These are called preprocessor directives. P-R-E-P-R-O-C-E-S-S-O-R. That is a really cool marker. It's writing just so dark. Directive. Preprocessor directive. It's almost like a meta language or a separate language on top of C++. What these are, all the preprocessor directives, these have their effect before the compiler even sees your code. I'm just so amazed I'm twisting my neck around to tell you that. Have their effect. Oh, has. I've got it singular up there. So preprocessor directive has its effect before compilation. And that is so surprising, I'll put an exclamation point. Compilation, remember, is when you run it through the compiler and it changes your source code, your .cpp file, into object code. All those zeros and ones that the computer can understand. Preprocessor directive, whatever the heck that means, it has its effect. It does what it's going to do before your code is even translated into machine code. That's one way to that's kind of an overview description. Another description, I'm going to call it my seat of the pants definition. I'm going to call it automated word processing. I'm sure you're all familiar with some word processor, like Microsoft Word, for example. Has all kinds of text editing stuff. For example, it has, good one, copy and paste. If you realize that paragraph, that came too late in my paper. That needs to be near the top where I'm explaining the general ideas. So you can cut and paste, or maybe you want to duplicate that paragraph. For emphasis, you can copy and paste. The reason I chose that one as an example of automated word processing, because that's very much like what happens with the #include. In fact, the #include preprocessor directive is copy and paste. So my example is going to be a picture down here. Maybe I should have called it a fig. Here's what you type, or what I typed in this example. In general, what you type if you want to use our brand spanking new super fancy TV data type that we just invented, then we would type a line like line number 10 that says in the main down here, I'll comment. This is the main, well actually it is the main program, but I'm going to call it by its name, example08.cpp. I might have overdone the caffeine, that's why it seemed kind of shaky and quick and jittery. But we do this, the pound sign include, I'll abbreviate because I didn't leave any space, include and then quotes tv.h. Now let me pause and reflect on that for just a second. You'll notice tv.h on line 10 is in quotes, but line 11 is in pointy brackets. I hate all these little secret signals like baseball signals or something. The double quotes mean look for that file right here. Look for that in the same directory where my source code file is. In other words, look locally to find that file called tv.h. The pointy brackets, IOStream, is another file. But that one was one that's provided with your compiler, downloaded off the web, all that stuff. It's part of the standard library. That's over in a separate directory just for those gigantic library files. The pointy brackets say, look in the standard library location, which is elsewhere on your computer, somewhere deep on the C drive, probably whatever. But it's telling the preprocessor to look in two different places for these. That's why the double quotes on tv.h, that's homemade. Look for that right here, where in the file folder where I am. The pointy brackets say, look over there in that standard place where the massive library is, our C++ Library of Congress. And the reason I acted so disappointed, that really is kind of a cryptic thing to do, but they didn't give us any choice. The pound sign in front, remember, that means it's a preprocessor directive. This is what we type. The tv.h file is completely separate. I'll put that up here, tv.h. Now I'll put an arrow there to show that we are using this preprocessor directive to include a copy of tv.h. We type, well, somebody else, some nice people developed the TV data class for us. Thank you very much. And they've got the H file with it and the CPP file and all that stuff. We're concentrating on just this one right now. I'm talking about just example8.cpp, and it has this line in it on line 10. Please include tv.h. That's what you type. Here's what the compiler sees. Try to keep this consistent. Here is tv.h again. Except the compiler gives you credit for it. Here, replacing the include, all the pound sign statements are gone by the time the compiler sees your code. What does this one do? Include means copy and paste the tv.h file right here, replacing the include line. So this looks to the compiler as if it's inside the top of example08.cpp. That's what I mean by the compiler kind of gives you credit for it. For all the compiler knows, you typed in all the lines of tv.h yourself at the top of that file. And you could do that. If you don't trust the includes, you don't think they're going to work the way they're supposed to. Of course they will. But if you really don't trust them, you don't have to use includes. You can find the tv.h file and just type in all the lines yourself at the top of example8.cpp. That's not recommended. I mean, every time we might want to use this fancy new TV data type, we're going to need to include tv.h. This keeps us from having to type it in every time. That's what the includes are for. IOStream is ginormous. You certainly don't want to have to type in all the lines of the IOStream file every time you want to use cin or cout. Thus, include the preprocessor directive. I hope I've made a case for why this is a good thing and why we want to do that. And that's actually an awful lot of talking about one line of the program. I'm not going to talk that much about each line of this program. What else do I need to say about that? A funny story I thought of when I was pre-drawing this picture. It doesn't look like that at all on my notes. But anyway, back in the day when I first started using C++ decades ago, compilers weren't quite as smart as they are now. And when it would give me an error message, maybe I had a tiny little hello world, one little cout line, return 0 down here, and I don't know, maybe I left off the semicolon or something. What it would do, I would have the include IOStream up at the top so that I could print stuff out. and then I had C up, hello C++ world. And the compiler, if it didn't know what CN was or there was a missing semicolon, it would say something like, error on line 798. And I thought, what the what? There are not any 798 lines in my program. But what was going on was it only saw the output of the preprocessor. And for all it knew, the compiler, for all it knew, I had typed in all of IOStream at the top of my program. So it really was way down here on line 798 or whatever I said, where it ran into my problem with the C outline. That was supposed to be an entertaining, funny story for nerds. If that didn't make any sense, then please erase that completely from your memory. It's not worth our valuable memory real estate with all the other stuff we need to know. I don't think I can say anything else about that, at least not that makes any sense. But that's what happens. This gets passed off to the compiler. You get credit for typing in tv.h even though you didn't do it. That's it. That's now, for example 8, that's it for that one line. Line number 10, I think it was. Okay, one thing I want to notice before I go any further, I printed this out with a fairly large font so I could read it, and it doesn't even take up a whole page. With my pictures and scribblings and stuff it does, but this program, example 8, is less than 1 page long. So it can't be that complicated, can it? And there are not even any functions. This is purely just the main program. Int may void, yada, 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 return 0. Back to the olden days of run and gun, one little main program. But let's keep going. Let's look at line, I was going to take my glasses off. Let's look at line 18. Line 18, there are only 2 variables in this program. One variable named Sony Plasma and the other variable named Samsung LCD. They are variables. What's their data type? Their data type is TV, and because I did play by the conventions with a capital T, that's a signal to me visually, the compiler already knew this, that that's a homemade data type. So what I have are 2 TV objects. You know what? I'm going to make these really bold. That's going to be ugly, but I can't back out of it now. Why? Because those are black boxes. We can't see inside that whoops. TV starts with I misspelled TV. Oh dear. We can't see inside the TV box. We get to use it in our program, but we're going to have to interact with it indirectly. We're going to have to go through the member functions because the TV object is not going to let us see inside. It's opaque. The old school term for that was information hiding. You can use your TV object if you want. You can't look inside it. How we do what we do is our business, not yours. I do have a name for it. This first one is called Sony Plasma. And I have another big black box. Maybe it's not that big, but it's a black box for sure. Can't see inside it. Another TV object, which is appropriate since we're in object-oriented programming. This one is called Samsung LCD. Let me see if I can spell that. Samsung LCD. I just spelled LCD. Those are my 2 variables. Now, when I'm going through what the main program is doing and all that kind of stuff, you might think, well, if those are variables, you should have left the bottom of that box open so you could X out the old value and change it and move on. Absolutely not. No. Any changes that are going on to the TV are totally happening inside the box. The main program doesn't know, doesn't care what's going on inside the box as long as the TV does what it's supposed to do, as long as it behaves appropriately. Now, how do we access the TVs if it's also mysterious and secret and everything? Well, let's take a look and see. After we get those 2 variables set up, there's a big, long C outline that I regret not splitting into separate C outs, but it's too late now. Starts on line 21, says initial state of TVs, couple of blank lines, tabs over, Sony Plasma TV /T channel. Finally, we get around to something more interesting. Look at the end of line 22. It says this, Sony Plasma dot get channel parentheses. Let me parse that for you. Let me take that apart, dissect that, and talk about it one piece at a time. Sony Plasma. I don't know what that is. That's just the thing right here, this object. Dot means I'm accessing something about a new data type that I invented. In this case, it's not a structure. We've used ASCII structures before. Things like my dog dot name would allow us inside it. A structure is transparent. You can see through that and set any of those variables you want. A class is not. The object that we make using one of our class definitions is not. So this is not transparent. It's opaque. The only way to get anything from it, to find out the channel or the volume or anything else going on inside the TV, is to go through the interface. The interface has a function, a member function, an accessor. I warned you, I was going to use all those terms. Has an accessor member function called getChannel. That's the name of the function. How does a computer know that that is a function and not just a field? Like the field of a structure, one of the variables inside a structure. Here's the giveaway, parentheses. Even though we don't pass anything into the Sony Plasma to find out what the channel is, we don't pass in any parameters, we still have to put the parentheses on there so the compiler knows we're trying to call a function. We're not just trying to access a field or a variable called getChannel. No, no, no. We are trying to call a function named getChannel. GetChannel, I'll draw a picture, and it's on Sony Plasma. We are calling function getChannel because we want to know what the channel is. And to tell the compiler this is a function call, you got to use the magic words open paren, close paren. Instead of open sesame, it's open paren. Open parentheses, close parentheses. It's a function. We call the function, and what happens? Well, the function does have a return value. Otherwise, our cout statement's not going to work. It returns what the channel is. In effect, it does what an accessor is supposed to do. It looks inside the TV, and I forget, even though I wrote the TV class, that was so long ago. When was it? Yesterday afternoon? No, it was longer ago than that. But it is going to send back a channel somehow from inside the TV. It tells us what the channel number is. Maybe the channel is currently channel 5. So here's the interaction. The main program says, give me the channel. Calls a member function. Somehow or another inside the TV, it figures out what the channel is and sends that back, and that's what we would print out. If, for purposes of argument and example, it is a 5, then it's going to say Sony Plasma TV, channel 5 on line 22. That's exactly what it will do. Now, it begs the question, how does it know channel 5? Is there a calculation? Maybe like changing Celsius to Fahrenheit, something like that? Or maybe that's in an array element. I don't know. Maybe it's you know what? That discussion is totally, completely worthless. The TV object, how do we do it? How does it get the channel? That is none of our business. If we were to try to ask the TV object that, it would say, worry about yourself. It's not your business how I got the channel. Here's the channel. Shut your mouth and print it out if you want to, but don't ask me where that came from. It's all the business of the TV object, totally opaque to the main program, meaning the main program couldn't figure out where that channel value came from even if it wanted to, aside from it being the return value of an accessor member function. That's all the main program needs to know. When you push a little button on your digital watch to find out what you've set your alarm to, it will tell you what you've set the alarm to. I don't think there will be any buttons on your little digital watch that explain how it figured out what the alarm setting was, where it's stored inside the digital chips and everything else inside your watch. That's none of your business. That's the watch's business. If the watch can do its job, that's all you need to know. If this TV object is capable of doing what it's supposed to do, that's all the main program needs to know. It doesn't need to know if that was a variable, if that's a result of a calculation, if we just generated a random number out of thin air. Doesn't know, doesn't care, and it couldn't find out even if it wanted to. Now, I have beat that to death, have I not? Let's look at line 23. 23 is almost the same thing. We call getVolume, the getVolume accessor member function on, that's how it's described, we call the getVolume member function on the Sony Plasma object. Getting all OOP about it, we call the get volume accessor on the Sony Plasma object. What that does, it gets the volume. Maybe a calculation, maybe a variable. We played that game before, didn't we, with the channel? Don't know, don't care. We say, give me the volume, and as long as the TV gives me the volume, I, as the main program, who am relishing my ignorance because I don't know have to know how it works to be able to use it. That's me with the remote controls on the TV. All I gotta know is which buttons to push. I don't have to know how it's doing what it's doing. So when I say give me the volume and the TV gives me the volume, I'm satisfied. The main program doesn't worry any more about it. It just prints it out. Now, the next line, moving right along, Samsung LCD on line 24. If you're playing along with your own source code, line 24 calls the get channel accessor on Samsung LCD. So over here, I'll draw another blue picture. This calls get channel. Samsung LCD, tell me your channel. And maybe Samsung LCD is set on channel 8. Where did that 8 come from? How did it figure out that it was on channel 8? Did it have that stored in a private variable or something? Don't even ask. Don't know, don't care, none of my business. Okay? Now, a couple of points before, this is the least efficient use of board space so far this term, I believe. But before I erase all this, get channel here gave me one value, get channel there gave me another value. That's because I'm calling it on two different objects. If you've got, let's go back, map it back to something that might be a little less intimidating to us. Structures, dog structures. Maybe dog structure number 1